Hi class, this is an example video for unit 6.1 and 6.2. 6.1 doesn't necessarily have a ton of stuff that I can demonstrate. We're just talking, 6.1 just talks about free body diagrams, basically, which is, ways that you can redraw a picture with just the forces there and kind of figure out how those sum up to zero. Unit 6.2 kind of builds on that, and it talks about equilibrium in 2D with 2 and 3 force members. And so to kind of demonstrate some of the principles of both of these units, I'm using problem 5-39 from the book, which looks like this. There we go. You kind of have this crane that's holding a box out there, and it is connected to the outside world by a pin joint at A and a collar at B. So one of the big things we learn about here in Unit 6 is about reaction forces and types of supports. So basically, we have all these forces acting on this system, and this member, the system, interacts with the outside world through supports and other things. And so for this to be in equilibrium, obviously this force here, we just have this 5,000-pound external force, that doesn't balance to zero. The way that this system is in equilibrium is that the points where it connects to the outside world, it's the reactions at the supports come together to cancel out the forces so that your member isn't moving. So we will learn all about the different kinds of supports, pins, rollers, cantilevers, cables, collars, bearings. But in this problem, we have a pin at point A. So instead of drawing the pin, I've drawn this is a free body diagram of that member I just showed. A pin has a reaction force in the X direction and the Y direction. So the way you think about reaction forces is those are those forces are the ways that support resists motion. So, right, if I have something pinned, I can't, if I can't shear it, right, if it's connected like that, I can't shear it, this way, I can't pull this way and have it move freely, but I can rotate it, right? The pin lets me rotate it, so there's no reaction moment that's resisting motion, but it is going to resist me trying to pull the whole thing this way or pull the whole thing this way. And then we have a collar at point B. A collar, right? If you were to take this out of the way, like I could slide this up and down easily, right? Because it's just a collar. So there's no reaction force in the Y direction, but it's not going to let me pull it this way, right? Because the collar would resist that motion. So reaction forces and moments are just the ways that the support resists motion, and if motion were applied in those directions, how it would keep it from going that way. So this is the free body diagram of that drum. We have X and Y at point A, an X reaction at point B, and what we're asked to find is those reactions at point A and point B. So we have 3 unknowns. And we have 3 equations we can use to solve those unknowns. We have the sum of forces in X, sum of forces in Y, and the sum of the moments. We know that all 3 of those have to sum up to equal 0 in a 2D problem to have equilibrium. Those are our conditions for equilibrium. So we have a choice on how we want to, where we want to start. We can start with the sum of forces in X. We have 2 unknowns in X, so maybe not ideal. We can start with the sum of forces in Y. We only have 1 unknown in Y, so that will work good. We also have the sum of the moments about a point. We could pick any point, but if we pick point A, then these 2 forces would cancel out, and we'd only be left with FBX, so that would be pretty good. If we pick point B, then FBX and FAY would cancel out. We'd only be left with FAX, so that would also be good. If we picked a point out here or something, then that would be not good because now we have all our unknowns left in that equation. So we have some options on how we want to proceed. So I'm going to Often I find it easiest if there's a really obvious place to put a moment that cancels everything else out except for one. I often like to start there. So I'm going to start by taking some of the moments about point A. But like I said, there's lots of ways to skin this cat. So I'm going to start with the sum of the moments about point A. It must equal 0. 0 is going to be f dx, magnitude f dx, times the y distance from point A, which is 12. And now I need to figure out the sign. Is that going to be positive or negative? So if I use right-hand rule, I'm going to stick my wrist at point A. I'm going to go towards f dx. Then my fingers have to point in the direction that f dx points, which is going to be that way. When I do that, my thumb points into the board, and I can see that would cause a negative, a clockwise twist, which we count as negative. So negative. And then we also have to include the moment caused by this guy. So we have 5,000. So force in the y direction, the distance in the x direction is 8, and then let's see, is that going to be positive or negative? And if we do right-hand rule again, we're going to see that's going to cause a negative twist. So it's going to be a negative. So when we solve for f dx like this, I'm going to trust that you can do the algebra here. F dx is going to be minus 3,333 pounds. Now it's a negative answer. What does that mean? That means that I just drew it wrong. When I draw the free body diagrams, I have to just place these forces in the direction I think they're going. My practice is to always draw them in the positive direction and then just go with it, right? And then if my answers end up being negative, I just know, oh, I drew it in the wrong direction. So what that really means is that the force on the collar is going to be acting in that direction. But as long as I'm consistent, and the way that I draw it in my free body diagram is the way I represent it in my equation, then I won't have issues. I'll just know that negative signs mean I just drew it in the wrong direction. It's going actually to the left instead of to the right. Okay, so that's one unknown down. So now we can do one of anything. So we still have sum of forces in x, sum of forces in y. I'm going to do sum of forces in y. I think that'll be pretty easy. Sum of forces in y must be 0. So what are my y forces? I have a minus 5,000 from the crate, and then I got a plus fay. So fay must be 5,000. And that's easy. Okay, so now last one, sum of forces in x must be 0. What are my x forces? I have 0 equals f dx plus fax. Well, I already know that f dx is minus 3,333. So let's plug that in. So minus 3,333 plus fax. So fax, the only other x force must counter f dx, 3,333 pounds. And that's really all there is to it. So it's the biggest challenge in this is drawing a good free body diagram. If you don't draw a good free body diagram, you are going to struggle in this unit. So learn how to draw a free body diagram. Learn, when you're given a roller, what sort of reactions is the roller going to have? What sort of reactions is a pin going to have? And these other things. All that is in your book. All that is in the notes for the class. And then just recognize, okay, I'm going to have a certain number of unknowns. I have a certain number of equations that I can use. If I'm smart about which equations I use in which order, I can usually avoid equations that have multiple unknowns. Not always. Sometimes you have to do some substitution magic, set one unknown in terms of another unknown and solve it, using simultaneous equations or substitution. But often you can avoid that if you if you think through what you're trying to do. So that is unit 6.1 and 6.2 in a nutshell. Obviously, there's a lot more to it. You're gonna have a lot of, there's a lot of questions on these units. So if you have any questions, don't hesitate to reach out and ask me. Thanks.